Good afternoon, class. We started section 8.3 last time. Okay, the law of cosines. So here's the synopsis of what we've done so far. We covered 8.1 and 8.2. First, refreshing everyone's memory about all the identities, basic identities or fundamental identities, if you will, in trigonometry that we should be comfortable with. Then we added the sine law. And the sine law says the right triangle, the sine law, and the cosine. The right triangle, simply put, if one angle is 90 degrees, the other two must add up to 90 also, because the sum of all interior angles is 180. So, and it follows Pythagorean theorem, so a squared plus b squared equals c squared. We looked at sine law that says the ratio of sine of an angle to its opposite side, for example, sine A over A, is the same ratio as any other angle. Find the sine and divide by the opposite side. So sine B over B or sine C over C. Cosine law, we showed that A squared equals B squared plus C squared minus 2BC cosine A. And if you recall, I mentioned that Pythagorean theorem is a special case of cosine law. What is so special about it? If you change A to 90 degrees, cosine A becomes 0. And it becomes the good old Pythagorean theorem everybody is familiar with. Okay, class? All right. So we looked at those formulas and we looked at the proof of that, the cosine law. And we did a simple example, okay? So side, SAS, side, angle, side, and that means an included angle. It has a solution, you go through the process, and you find that it's very straightforward. So what we want to do, we want to move on and look at more examples like that, okay, class? I believe this was the last page we covered. Am I correct? So let's put it in slide mode. And move on from here. So we did this example. So this is just a quick recap of that. A and B are given. C is 60 degrees, okay? And so how do we know this is the included angle? Because of the way we name the sides and the angles. And so we used the cosine law, okay, to solve for C, and then the rest follows. Whether we use cosine again or not, it really, you have a lot of choices, okay? At this point, you may be able to use, you know, the sine law to get there. For the sake of the section, we use the cosine law, but understand, for the first step, the cosine law is a must, then finding the rest of it, you have a lot of choices. All right, and so we got those. Let's look at this example, class. Now, this is the example where we have three sides given. A, B, C, all sides are given, and therefore all angles are missing, okay? All angles are missing. So what we need to do, we need to find out the angles. So can anybody tell me what would be a good formula to get this started with? What would be a good formula to get this started with? Remember, we have all the sides, yes? So we need all the angles.
Mm-hmm.
And anything comes to mind? Okay. Take a look at the
The
bottom
formula
formula.
and things?
Yes, the bottom formula in red or in purple gives you A. Cosine A is B squared plus C squared minus A squared over 2BC. And notice, again, basically you are solving, let me pick a color here, class. So you are solving for cosine A here. In other words, even if you don't remember the second formula, you can make it up. I hope you see that you can make it up. So using that plug-in, you got just about everything. You can find cosine A. Does that make sense, everybody? So
Yeah.
this is what you do. You're practically done. Simplification gives you 29 over 36. I hope everybody can see 3 squared is 9, 6 squared is 36 minus 16, and the bottom is 36. And this is what you have, and it can't get any more simplified. You can keep it as such, and now you use your calculator to find A, because it is not a common arc. It is not a common arc. So with that being the case, the answer is the cosine inverse. Okay, the answer is the cosine inverse, class. So now, what do you do next? Again, we want to use cosine laws for the sake of the section. But can we use sine law, class, also? Can we use sine law, or we have to stick with cosine law? Houston, we got a problem. I hope you guys have done studying on the weekend. We have a couple of weeks ago, we had one more exam and the final. You really got to be at top of your game. This thing is going to get much more involved. Okay, remember, you want to find two more angles. Okay, you really can use any of them. You can use the sine law, okay, or you can use the cosine law. Okay, so for section we can continue with cosine law. All right, so we found one of them. We find another one using cosine law. Now, let me change the formula, class. Really, this is B, okay? All right, so A squared plus C squared minus B squared over 2AC. The formula is right, class. I'm looking at the formula. The formula is right, but it's cosine B that we are looking for, okay? Cosine B, so that's the one that you want to be careful of. This is cosine B. All right, so with that being the case, again, it's a simple calculation. You plug in and you end up with, again, a number which is not a common arc. So what do? We do exactly the same thing. Inverse will do the job. And how would we find the last angle? What would be the best course of action, class?
Subtract from 180.
That's it. Again, the point being, you really want to take the easy way out whenever you can. Whenever you can, class. And if you can't, understand. But whenever you can, you must always take the easy way out. Is this the only way? No, no. You can use the cosine law. You can use the sine law. I mean, you really have a lot of options here at this point. Okay, class? But take the easy way out whenever you can. All right, sounds good. Everybody okay with this? Is there any questions? All right. We are going to move on to the next one, everybody. I hope everybody's okay with this. Okay, so we're going to move on to the next question. So here's the next one. Could somebody be kind enough to read the question for us, please?
A boat leaves Naples for Key West 150 miles away at 15 miles per hour. It encounters heavy crosswinds and strong currents. The crew finds after 4 hours that the sailboat is off course by 20 degrees. A, how far is the sailboat from Key West at this time? B, through what angle should the sailboat turn to correct its course? C, how much time has been added to the trip because of this? Assume that the speed remains at 15 miles per hour.
Well, thank you so much, Mercedes. So we want to find the distance between the two cities. And I hope you see that we can use cosine law as follows, okay? Remember what the cosine law says? A squared equals b squared plus c squared minus 2bc cosine a, okay? So we can find x this way. So we are trying to get to the distance between the two cities, but what we have is different here. So we're going to look at what is given, okay? And so plugging in, remember class, this is x squared. Remember, this is x squared, okay? So x is the square root of that. Everybody understands this one is the square root of that number. Again, this is a rough estimate. When you have doubts, you can always use more decimals. So we take a square root, okay? And we find this distance. Let me just show you the distance. Okay, class. Everybody, okay. Yeah, I made it thick enough so everybody can see. This is the X amount. This is the distance. That works for everybody? We were interested in finding that distance, okay? How far is the boat from the city, okay? So that distance in yellow, or sort of yellow color, is found to be about 96 miles, 95.8. All of this is an approximation. So if you have been told how many decimals you use it, if not, I would recommend a couple of decimals just to be on the safe side, okay? So that takes care of that. Now, that's part A. Part B says, through what angle should the sailboat turn? So the turning takes place with the angle theta, okay? So let's see what we have here. So take a look at the drawing. I hope everybody can see the drawing and which one is angle A. So let me, you can see the A, right? Let me use a different color. Maybe red is a good one here too. Okay, this point gives us the angle that we want. Is everybody clear? So when we find that, whatever that may be, we're going to find out. Everybody can see that if I subtract that from 180, I get to theta, right? That works for everybody. So if we find A, we are almost there. How do we find A? Of course, we have the triangle. Okay, we have all the sides. One side is 60, one side is 50, one side is X. We found it to be 96 or 95.8 miles. And we have one angle to be 20 degrees. We can find that angle either using the sine law or the cosine. It makes no difference. Okay, class? And so now we use a squared equals b squared plus c squared minus 2bc cosine a. Remember, that angle is the included angle, okay? So the side opposite the included angle, okay, is 150. So that is the one which is 150 squared equals the side squared, 95.8 squared plus 60 squared. Now minus 2 times the two sides, 95.8 and 60, and cosine A. So this is the formula we are going to use, cosine law. Again, before we do that, again, understand what this means. When we find A and we don't know what it is, we can easily get to theta, because all we have to do is subtract it from 180. And so when we do that, we can find cosine A. Now, I'm not going to worry about the, counting and arithmetic. You all can do that. It's very straightforward. And you do the math. This is what you get. Okay, understand how we arrive at it. You got a square 150. You got a square 95.8. You got a square 60. And subtract the sum of the two from 150 squared, okay? On the right side, we have negative 2 times 95.8 times 60 times cosine A. Now we divide by negative 11,520, and cosine becomes negative 0.8406. Again, I have no idea what that angle is because it's not a common arc. We use the inverse function to get to A. So the inverse function gives us the A. I can't emphasize this enough, everybody, the inverse function, okay? Okay. Now that we have A, What is theta? 180 minus A. 180 minus A. And so that's theta. So we got theta to be 32.8. Okay. So that's part A and part B. Part C says how much time has been added to the trip because of this. And we are assuming that we are doing 15 miles per hour. Okay. So all we have to do as far as the added time is concerned, we look at the added distance class. And that gives us the added time when we divide it by what? The speed. Okay. So that's how we arrive at the answer. So what is the added distance? Well, instead of going 150, we're going to go 60 plus 96. Okay, 60 plus 96, that means we went 6 miles more than expected. So that 6 miles, okay, when we divide it by the speed, okay, that gives us 6 over 15. That's the amount of time, okay, and because it was miles per hour, 6 over 15 hours is the amount of time that has been added. Is everybody okay with this? Can anybody tell me what does this mean? Because normally when we report something like that as far as time, we don't tell anyone, okay, it took us 6 over 15 hours, right? Can anybody tell us how many minutes it is? Class?
So would we divide the 6 by 15?
We can do that, sure.
And then the multiplication, I assume, by 60?
Yes, absolutely. So
So 24 hours?
24 minutes.
24 minutes, there you go.
Yeah, that's how you do that. You multiply this number by 60. That's the bottom line. And therefore, if you multiply just the way it's by 60, it's the 60 divided by 15 is 4. 4 times 6, 24 minutes. Okay. I'm assuming we are ready to move on to the next question, class. Does that make sense? Everybody is okay with this? All right. So it's 24 minutes. Here's the next. So everybody has that, right? 24 minutes was, I mean, you know, I mentioned that, but again, in case. So we are good to go. We are ready for the next one, class. So we are looking at the applications because I think we have a fairly easy time when it comes to solving any type of a triangle. So let's see some applications. Okay. So here's the next one we're going to look at. All right. Could somebody read this one for us, please?
Yeah, I got it. An airplane flies due north from Fort Myers to Sarasota, a distance of 150 miles, and then turns through an angle of 50 degrees and flies to Orlando. a distance of 100 miles? A, how far is it directly from Fort Myers to Orlando? B, what bearing should the pilot use to fly directly from Fort Myers to Orlando?
Thanks, Eric. Okay. So remember, the most important thing is to have the diagram. They have given us the diagram. So practically, they have given away the question. So with that being the case, we are going due north, 150 miles. Okay, so we have this distance. So we have this distance. $150. We have this one as 100 miles. And so basically, we are interested in finding this distance. And we can use cosine law. To do that, we need the two sides. We do have them, 150 miles and 100 miles. We also need this angle, class. How much is this angle?
130 degrees.
Very good, because 180 minus 50. So the very first thing is to see the given, and then from the given, find the ones that you're interested in. So the two sides are given. The included angle is given. You can find the distance between the two cities. A squared equals b squared plus c squared minus 2bc cosine A. Okay, we are calling this one A. Just give it any number, or X, whatever you want to call that, it doesn't matter. And now, if you have that, your B and C, one of them is 150, one of them is 100, and capital A, it's 130 degrees. Okay, now I'm not going to go through the process of that. You have to use a calculator. Everybody knows how to do that. And you finish the job and you find the distance to be 227.56 miles. Roughly. Sounds good? Everybody is okay with that?
Yeah.
Yeah.
Now, so that takes care of the first one. Then it says, what bearing do we use to go directly to Orlando? Okay, we can see the bearing is north, some angle, we don't know yet, and it's to the right of north. That means east. Do you agree? So what we need to know is, what is this angle? As long as we have it, we are done. So one more time, north, let's call it capital B, whatever it might end up being, and then east. That is our bearing. So as long as we calculate the value of B, we are practically done. Agreed?
Yes.
So we do the calculation, class, okay? To find B, remember B is the included angle, if you will, okay? And you go through the process. The opposite side, remember the opposite side is 100 So that's 100 squared, okay? So you're looking at a squared equals b squared plus c squared minus 2bc cosine. You can always use the same formula. Understand the meaning of that. The meaning of that is, what is that? A is the one that is opposite the angle of interest. So the opposite of angle B is 100 miles. Do you see that? So let's see, let me use a different color. The reason I'm mentioning this because even with one formula, you can repeat using it as long as you understand the meaning of it. This is the included angle. And 100 miles is the size of the opposite side. And that's how, and the two sides next to B, angle B, one of them is 150 miles. And the other one, we found it to be 227.56 miles, okay? All right. And so either way, you use that or the sine. As I mentioned it before, class, you really have a choice in many cases after you do your first step. And sometimes one is easier than the other. So if the sine law comes to mind nice and easier, so be it. For the sake of a section, we are doing this. You don't have to. So now I'm going to assume everybody can do the math, come up with the answer. So I wouldn't worry about that. And B becomes 19.7 degrees, which means what? What we just discussed. North 19.7 degrees, east would be the answer we are looking for. Okay, everybody? That's the answer we are looking for. Okay. We're going to go to the next example. Is everybody okay with this class? Okay.
Yes.
Perfect. Now, please understand, we really have to go over these questions again and again to get really comfortable with that. With a little bit of a practice, we will be there. Okay, I promise you. But you need to practice class. I'm going to go to the next example. So here's the next example. Okay. Let me close the door. There's too much noise here. Could somebody read the question, please?
In attempting to fly from Chicago to Louisville, a distance of 330 miles, a pilot inadvertently took a course that was 10 degrees in error. A, if the aircraft maintains an average speed of 220 miles per hour, and if the error in direction is discovered after 15 minutes, through what angle should the pilot turn to head towards Louisville? B, what new average speed is needed to keep the total time of the trip at 90 minutes?
Thank you so much. So all of these are calculations that The aircraft, the pilot, and people in charge should figure out, okay? Okay, let's do this. First and foremost, we are going in a wrong direction for, let's see, how long? 15 minutes, okay? And what is our speed, everybody? We are doing 220 miles per hour. So what distance do we cover if we are doing 220 miles per hour over the course of 15 minutes? We have to multiply the speed by time. So what is our timing, everybody? How would we write the timing? So we want this distance, right? And this distance is simply d equals RT, the rate times time. The rate is 220 miles. The time is 15 minutes. 15 minutes, that means if it's given in minutes, you just divide by 60, class. And I don't want to, everybody knows it's 1/4, but I want to keep it as 15 over 60 for one reason and one reason only. What if it's a number like, let's say, 7? So it's not, you know, there is no common factor between the top and the bottom, okay? So this is 15 over 60 or 7 over 6, any number of minutes divided by 60. So we cover a distance of 55 miles, okay. All right, that sounds good. Now, what we need to do is to find this angle. And in order to find this angle, we can find this one and subtract from 180. Agreed? And to do that, then we need to find the side next to it on the right side, okay? So we need to find the angle that I showed you in yellow. To get that, we use the cosine law to find all the sides, okay? And then we use another cosine law to find that angle. That's the concept, okay, class? So if this side, we call it A, and we use the cosine law, remember, this is the opposite side of 10 degrees. Do you see that? That's opposite side of the 10 degrees. What do we have? For 10 degrees, we have both sides. One of them is 330 miles. Okay, so what do we have? I want to make sure everybody understands what we have so we can use this law. This is the included angle that we have. Sides are as follows. So we have a 10 degrees and the sides are 330 miles and 55 miles. And we can calculate A using this formula. So one of them is considered to be B, one of them is considered to be C. Since this is C, then we're going to call this one lowercase b. Let me just rewrite this. Okay, so this is lowercase b, everybody. All right, so now plug in. A squared, the missing side we are looking for, is B squared, which is 330 squared, plus C squared, which is 55 squared, minus 2 times B times C, 2 times 330 times 55, cosine A, or cosine of included angle, which is 10 degrees. Now you just do the math and you find A to be 276 miles. Again, you really want to give it, well, the way that it's given 330 miles and then 55 miles, it appears that, you know, you can round it to the nearest mile. That's okay. If you have any doubts, go with a couple of decimals to be on the safe side. Okay, go with a couple of decimals to be on the safe side. Okay, so with that being the case, now we are ready to find the missing B. Okay, this angle B. How do we find it? You can use the sine law class. You can use another cosine law. For the sake of a section, we use another cosine law. You do not have to. Okay, why is that? You have all the sides and you have one angle, so you can use any of it. I can't emphasize this enough. It is your choice. So with that being the case, in order to find capital B, the opposite side is lowercase b, okay? So in essence, you really use this formula that b squared equals a squared plus c squared minus 2ac cosine b, okay? You don't even have to memorize that. Just, you know, as I said, remember the opposite side is going to be on one side, everything else on the other. And so with that being the case, 330 squared is 276 squared, okay? One side, which is A, plus C, 55 squared, minus 2 times 276 times 55 times cosine B. Before we move on, I want to make a point, class. It appears that C is larger than A in the diagram, but that's really not the case, and that's not what we worry about. We just have a rough diagram, and things may not be to scale, and it doesn't matter, okay? So you go through the process, you find cosine B, it's not a common arc, you use the cosine inverse, you work it out. So there are a lot of steps missing here. You really should have no problem filling them up, the missing ones. So if B is 168, what we want is 180 minus that, okay? That would be the answer to part A, everybody. Now, to answer part B, it says, what new average speed do we need if we don't want to go beyond 90 minutes? So you are the captain and you're making a decision how to adjust because, okay, you don't want a trip to be longer than 90 minutes. Okay, we have already wasted 15 minutes. So what is left is 90 minus 15 or 75 minutes. 75 minutes, by the way, is 60 minutes plus 15 minutes. 15 minutes is 1/4 of an hour. We already know that is 1.25, okay? And so D equals RT, everybody knows that. where d is the distance, r is the average speed, time, t is the time, okay? So what is missing is r. If d equals rt, that means r is equal to d over t. Now, what is the distance? The distance is a, lowercase a, which is about 275 miles. What is the time? We just came up with the time, 75 minutes. Why are we changing it to 1.25? Because of the proper units, okay, class? All right, because the speed will be in miles per hour. So one more time, 75 minutes means 1.52 hours. Why are we changing it? So we have it in hours. D equals RT, that means R is D over T. Distance is given as A being 276 miles. Okay, class, this is a rough, number. You can double check to see, if it's correct or not. But in any event, 276 roughly, okay? And you divide it by the total time of 1.25 to get your speed. So if you do about 220.8, 221 miles per hour, you make it on time. So, and things like that sometimes happen, okay? So this is the process of taking care of the business. I hope everybody's okay with that. Let's look at the last question of the section. Before we do that, any questions? Everybody okay with this? Class, we're doing okay?
Yes.
Perfect. All right, let's go to the next one. Okay, could somebody be kind enough to read this for us, please?
A radio tower 500 feet high is located on the side of a hill with an inclination to the horizontal of 5 degrees. How long should two guys' wires be if they are to connect to the top of the tower and be secured at 2 points 100 feet directly above and directly below the base of the tower?
All right. Thank you so much. Let's see what is given here. So we do this, okay, again, we are just repeating the same thing, but we make it slightly better to understand and look at the sides and the ones that we want. One of them we're going to call it X, one of them we call it Y, or call it anything you want. Okay. All right. So let's look at what is given. Okay, the height is 500 feet. That's okay with everybody? Yes? Each side, 100 feet, 100 feet, and then X and Y are missing, okay? Now, you see angles put there, but let's discuss those angles, because when we go back to the given, the only angle given is 5 degrees. Everybody understands that. This is the only one that is given, right?
Yes.
Okay. So I want to discuss the rest of them. So take a look at what happens. If you continue with that line, okay, that vertical line, okay, I want you to look at the triangular shape, the small one in blue. Everybody can see that you continued with the vertical line, if you will, and you have a 90-degree angle, and the small angle on the side is 5 degrees. So take a look at this one. I want you to see that this is the little one. And this angle, class, let me use a different color to make it. Okay. This angle is the same as this 5 degrees. Is everybody with me so far? So if this is 5 degrees, this one must be 90 minus 5. So that one is 85 degrees. Okay. So if that one is 85 degrees, let me now use another color to show you how these things work. Let me go with yellow. So if you continue this one, and if you continue this one, this angle is also 85 degrees, and that's what this one is. I hope everybody is following what I'm doing here. So one more time. 5 degrees is given. We can come up with a triangular shape. If one angle is 5 degrees, the one in blue, then the other one is 90 minus that, or 85 degrees. Okay, everyone? If that one is 85 degrees, we can easily see the opposite angle is the same thing. And then finally, check this out. Now this color. Class, this angle is 180 degrees. So what is left is 95 degrees. Can everybody see how we come up with those angles, class? Because that is the hardest part, using geometry and trigonometry to figure out based on the fact that only one angle is given, what are the other ones? Okay, class? So 5 degrees is given. We come up with 85 degrees for the other angle that the right triangle makes, and from there we find the two angles we need to help us find x and y. Now we can use cosine law. Okay, notice what's happening. If you look at this piece, you can find x, because x squared is 500 squared plus 100 squared minus 2 times 500 times 100 times cosine of 85 degrees. Again, I'm not going to do the math. It's a simple math. You can go through the process, plug in, take a root, use a couple of decimals, and x becomes 501 feet, roughly 501.28 feet. If you use, let me use a different color here. This triangular shape. One side again is 100 feet. One side is 500 feet. This time the angle is in between is 95 degrees. So you use 95 degrees instead of 85 degrees. And you write the same formula that you wrote. You just change the cosine of 85 to cosine of 95. And that gives you the value of y. Again, how do you calculate the y? You go through this process to calculate it, okay? And it gives us 518.38, roughly about 519 feet. It's a little bit longer, okay? And of course, it was obvious from the shape, 95 degrees is larger than 85 degrees. The two sides are identical. So therefore, the opposite side of 95 degrees must be a little bit larger. And it is, so it does work. Any questions? Is everybody okay with this class? Okay. Rather than starting the next section, we can take a few minutes of break. Let me pause the recording. All right, class, we are looking at Chapter 9, Polar Coordinates, Vectors. The first section is about polar coordinates. So, what are we going to cover in this chapter? We're going to look at polar coordinates, polar equations and graphs, the complex plane, De Moivre's theorem, and vectors. So in this section, we're going to look at plotting points using a different coordinate system known as polar coordinate system, and convert from polar to rectangular and vice versa. Okay, we do the same thing when it comes to their equations. So this is the synopsis of what we are going to cover in this section. And again, it's extremely important to remember the identities that we have learned in trigonometry. Okay. And let me put this in slide mode to get us started. This is the synopsis of the section. So let's just quickly go over that, making sure everybody is following what's happening. Everybody knows what's a rectangular coordinate system. In rectangular coordinate system, you have x comma y. So every point can be known with a unique x comma y. Okay. So for example, if you're looking at P, this point, as you can see, has coordinates x comma y. Now, there is another way of referring to point P. We can represent the P and locate the P, okay, with the distance it makes from the origin and the angle that it makes with the x-axis. So distance from the origin, or an angle that it makes with the x-axis theta. So x comma y can be represented with r comma theta. So if that is the case, the x-axis, now we call it a polar axis. Okay, class? The origin, we call it the pole. It's just the same thing. Now, many times when we do these graphings, we put the two of them together. So the x-axis is considered the positive side of it, is the positive side of the polar axis. Okay, class? Many times we use the two grids together, if you will. All right? Now, the difference between the two pairs is that when you have x and y, it's unique. But r comma theta is not unique. Why not? Take a look at this. If we use, instead of theta, theta plus 2n pi or 2k pi, I've already mentioned that sometimes we use k, sometimes we use n. We are coming to the same location if we use 2k pi and add to theta. It's what? So many revolutions. 2 pi is 1 revolution. and 2k pi is k revolutions. So a pair in rectangular coordinate system is unique, end of the story. In polar coordinates, it's not. Normally we use R and theta, again class, normally we use R and theta, but we can use R comma theta plus 2k pi, or in fact, if we want, we can use negative R. Normally we use positive, but can be represented with negative R? Yes, the opposite side. And in which case, we will have to add a pi. So for example, R comma theta plus pi. Okay, so if that is the case, this as an example is the same as negative R comma theta plus pi as an example, okay? Or theta plus 3 pi or 5 pi or 7 pi, okay? Now, as you can see, x equals r cosine theta, we had already seen that. Everybody remembers the unit circle and not unit circle, just a circle, okay? And the way cosine was represented and so forth, right? Cosine was x over r. I hope everybody remembers cosine was x over r. And you don't have to even remember that. Just look at this triangular shape. Okay, look at this shape. If you look at this triangular shape, you can see that cosine theta is x over r, therefore x is r cosine theta, and sine theta is y over r. And therefore, we have those formulas. The formulas, I think, should be familiar. We have seen them. That's why when we covered the trigonometry and unit circle and how a point is represented, when we look at x comma y, and in the unit circle, x is cosine, y is sine. If it's not a unit circle, cosine is x over r, sine is y over r. I hope everybody remembers that. And then in the case of a unit circle, everybody, x squared plus y squared was equal to 1. Everybody remembers that. But if it's not 1, and it's centered at 0, 0, it's x squared plus y squared equals r squared. Okay. And as you recall, tangent, as always, is what? You can say y over x or simply sine over cosine. Either way, it gives you y over x. Now, as far as finding the angle for the polar coordinates, you really have to figure it out based on the quadrant class, okay? You have to figure it out based on the quadrant. And you know what that means in a moment as we look at a couple of examples. So, if we understand this page, the whole section becomes easy. So what is this section telling us? A pair x comma y can be represented with r comma theta. R is x squared plus y squared, take a root. And theta, you can use tangent to find it and pay attention to the quadrant for the proper answer. X is r cosine theta, y is r sine theta. All right, let's get this started, see how it goes. All right, we want to plot this point. Okay, the way it works, class, again, normally for the polar grid, you really don't need a rectangular grid. But if you want to use a rectangular grid, okay, I don't want to, and let me just use a different color just to make a point here. Understand really this now, okay, so this is a rectangular grid. and this blue one is your polar axis. And now just that one represents your polar grid. So if I want to find 2 comma pi over 4, I have to find pi over 4 first, everybody. Okay, so that means I cut this in half, and this is pi over 4. Now I have to go how many units? 2 units. So let me use a different color to show you what I mean by that. So now let's say this is 1, this is 2, and this is the point. So this is the way you show that if you want to use a rectangular grid. Look at the way it works. You have your polar axis, you have your pole or the origin, whatever you want to call that, okay? And see that you have to come up with pi over 4 first and then go 2 units along that line, 2 units. I hope everybody is comfortable with this. Okay, I hope everybody is comfortable with this. Okay, let's see. What if we want to plot a pair where R is negative? Normally, we don't go with that, but here's the process. Take a look at R comma theta, where R is negative. So first you draw the theta. Let me make sure everybody understands. You draw the theta. When you draw the theta, this side is the positive side. The opposite side is the negative side. So if I want R to be negative, then I count down the opposite side of that. So in this case, 2 pi over 3. So I want to go back to my grid that I have up there. Okay, and now we use a different color. This is the green. So if I go to this grid class, I have to start from here, and I go what? 2 pi over 3. Okay, this is the green one is 2 pi over 3. But I want negative 3. If I wanted positive 3, let me just show you the positive 3. Let's assume this is 1, this is 2, and this is 3. This point would be positive 3 comma 2 pi over 3. But since I want negative 3, I have to go in the opposite direction for 3 units. Okay, so I gotta go this way. So here's how it looks like. Take a look at the blue one is the positive side. The red one is a negative side. You count whatever your tick mark is, whatever your scale is. That's not a big deal, okay? And you have negative 3 comma 2 pi over 3. So I hope we can plot points. It's not a big deal. Here's the next one, everybody. All right, part A, 3 comma 5 pi over 3. I'm going to put the answer up in a moment. Okay, if you want to try that or do it in your head. First, you have a polar axis, or you can even go with the rectangular grid. That's fine with me. You draw the angle of 5 pi over 3. Which quadrant is 5 pi over 3, class? If we were to go with the rectangular grid, it would put us in which quadrant? 5 pi over 3. Anyone? Which quadrant is 5 pi 3 in? First, second, third, or fourth?
Fourth.
Fourth. So you have that, and how many tick marks? 3 of those. So that's how you arrive at it. Okay, very simple. It's really not a big deal. The next one, you draw negative pi over 4. Remember, from the polar axis or from the x-axis, if you go counterclockwise is positive, clockwise is negative. So you go down, and then you count. In other words, you go to the fourth quadrant, and you count how many? Number 2, 2 tick marks. Just for the sake of argument, I hope everybody can see. This is also equal to 2, 7 pi over 4, because this is 7 pi over 4, just as an example, okay? Does that make sense? All right. We want to draw 3, 0. That means we got to do 0 first, meaning 0 degrees, meaning on the x-axis, on the positive right of the side of the x-axis or the polar axis, and go 3 tick marks. That's very straightforward. That's very obvious. For the next one, negative 2, pi over 4. You do pi over 4. And you have to go 2 tick marks in the opposite direction. Okay, class? Opposite direction. So I hope everybody is okay with that. Now, just as an example, this is the same as 2, comma. I don't want to use the negative one. What should I write? 2, what? Can anybody tell me? 2, anybody? 2, just add a pi, class. Add a pi, remember that? Or add 3 pi, or 5 pi, or 7 pi. Okay, if you want to change the sign of R, everybody, if you want to change the sign of R, add or subtract pi from theta, or odd multiples of that, and remember that. All right, we're going to move on. Sounds good? Is everybody okay with that?
Yes.
Okay, we are practicing, class. We are practicing with graphing because a lot more interesting thing is coming our way. If we get this part, then believe me, the rest goes fairly easy. The hardest part is figuring out how to plot points, believe it or not. When we get comfortable with that, the rest goes easy. Here's the next one. We want to plot this point. By now we have, I think, a fairly easy time. So first and foremost, we draw pi over 6. That was in the first quadrant. And we go with 3 tick marks up. So that's very straightforward. That's the graph. And I hope it makes sense to everybody. Very straightforward, very simple. Here's the next couple of questions we want to do. Part A, we want to plot P such that R is positive. That means you use the same number 3. That doesn't change. But this time, theta is between 2 pi and 4 pi. Between 2 pi and 4 pi. What do you think we should do? Two pi and 4 pi, that means the second revolution. Do you follow what I'm saying, class? So basically, you keep the r the same. You just add 2 pi to this guy. Okay, 2 pi, when you add it to pi over 6, gives you 13 pi over 6, and it gives you the same location. Everything is the same. We are keeping r positive. Okay. Now we want negative r. So take a look at what I said, or if you take a look at this one, it says if you want negative r, all you have to do add pi or more pi and 2k pi. That means, again, it's really important to know when we say pi plus 2k pi means odd multiples of pi, okay? 2k pi means what? Even multiples of pi, okay? So one easy way, just add pi, okay, class? Add pi. So if you change this to -3 and you add pi, notice what happens? -3 and then pi plus pi over 6 gives you 7 pi over 6, and you're done. I hope we are getting comfortable with the concept again. Finally, for this example, we want to plot P so that R is positive. We're going to keep the R positive. Okay, class? We're going to keep the R positive. So 3 remains. Okay. And then we want theta to be between 0 and -2 pi. Okay. So basically, all you have to do is subtract 2 pi from pi over 6. So just, you see this one? Look at the theta. Subtract 2 pi. Subtract 2 pi. So you get the same number, r is 3. And then pi over 6 minus 2 pi is -11 pi over 6. Again, the purpose of this question is to let you know there are infinitely many ways to represent a pair with polar coordinates. However, the rectangular coordinates, one unique format. Okay, class? Sounds good? Everybody is okay with that?
Yep.
Okay, class. I want to move on. I hope everybody is fine with that. So here's the next one. If you want to convert from one format to the next, it was already discussed, so I'm refreshing your memory about what we said. Okay, class? X is r cosine theta, y is r sine theta. So let's look at this simple example that takes care of the business here. We have a pair 6 comma pi over 6. And we want to find its coordinates in rectangular format. Well, x is simply r cosine theta. y is r sine theta. Okay. This is graph. Everybody can plot the pair. That's why I said, you know, if you want to use the pair and actually use the rectangular coordinate and the polar coordinate system combined, that's fine. Sometimes it's really helpful, especially when you want to graph functions and equations. You'll see that. In any event, what is x r cosine theta? And it ends up being 3 square root of 3. I'm assuming we are all very familiar and comfortable with common arcs. And what about y? R sine theta. And we write the pair as 3 square root of 3, comma 3. And that shouldn't be a big deal. So what I want you to do, I want to give everybody a minute. I'm going to pause the recording. See if you can do the same thing for the next one, part B, if you can graph that. Okay, look at the solution that is posted. See if you can graph it on your own, come up with the answer. I'm going to pause the recording, give everybody a minute. All right, class. I hope you're comfortable with that. Okay. So you're going to go with negative pi over 4. Everybody knows what that means, clockwise. So you're in the 4th quadrant. Okay. And then because we have negative 4, we go in the opposite direction. So that's a graph. I hope you have it. That's a graph. I hope you have it. Okay. So negative pi over 4, because r is negative 4, we can have it. And again, one easy way you can basically do positive 4 and then negative pi over 4. Just add a pi. This is another way of drawing the class. Okay, just for the if you have a hard time with the negative r, that's fine. Do not graph r when it's negative. Just add a pi and graph it, and that might be more helpful. So x is r cosine theta. Okay. Cosine of negative pi over 4 is the same as cosine of pi over 4. Everybody knows that, because cosine is an even function. Now, r sine theta. Now, sine of negative pi over 4 is negative sine pi over 4. Negative times negative 4 makes it, you know, so sine of negative pi over 4, and it's positive 2 square root of 2. Okay, class? Okay, this is wrong. Okay, so let me just, if you want, you can put a negative here and make this positive. Okay, everybody? So again, it's positive, class. It's positive, and the reason why, let me actually show you this one. It's extremely important. So this is the same as negative 4, okay, times negative sine of pi over 4. Why is that? Because sine is an odd function. Sine is an odd function, class. Okay, that's why. And so the pair has coordinates negative 2 square root of 2, comma, positive 2 square root of 2. Again, I hope you see everything comes together. Everything that we studied in trigonometry portion of the course, you should know that. The common arcs, identities, you know, formulas from when we are dealing with a unit circle or otherwise, and all of them will be really helpful here. Okay. So I'm assuming we are okay and done with this. Here's the next example. We want to convert from rectangular coordinates to polar coordinates, okay? And again, at the bottom, I have the general idea how we do that, okay? Generally speaking, you want to graph it for the sake of finding theta, actually. And this is very straightforward. It's one of those, you know, questions that you should be able to answer in no time. When you plot that x comma y 0 comma 3, you can see the rest of it, okay? So to determine the r and theta, remember, r is 3 and theta is pi over 2, as you can see this obviously, okay? And so here's the answer, and there are a couple of ways to write them. So here's the answer that we are interested in, okay? But it is not unique, okay? For example, we can add 2 pi, or if we change this to -3, then we can either add or subtract, for example, pi. So if you subtract pi, you get this one. If you said, I'm going to add pi, that is okay too, okay? In other words, instead of this one, you can write -3 and +3 pi over 2. That has the same meaning. As you know, 3 pi over 2 is the same as -pi over 2. So this is not unique. We are interested in the first one mostly, but you don't have to. You can have the other two as well, okay? So you plot the point and you try to figure out r and theta. If it's this easy, so be it. If it's not, you have to go through the process. What is r? X squared plus y squared equals r squared. Take a root. What is theta? Tan theta is y over x. Find theta, adjust it for the quadrant. Which quadrant? Make a decision, okay? Accordingly. So let's look at some of the easy ones you should know, okay? Let's quickly look at some easy ones. All right. If the coordinates are x comma y as a0, that means if the point belongs to the positive side of the x-axis class, and it's a units away from the origin, x comma y becomes a comma 0. Everybody knows that, right? Okay. Now, in this case, r comma theta, okay, so both of them become the same. X comma y and r comma theta are identical under one condition. What condition is that? If it's on the positive side of x. Okay, class? Positive side of x. Positive side of x. All right. If it's on the positive side of y, we say 0 comma a, right? But this time is a comma pi over 2. Remember, in the case of a polar, we start with r first, okay? R comma theta. But for drawing it, we start with theta. Class, we write r comma theta, we draw using theta first. I hope that sounds good. I hope everybody's okay with that. So positive side of x, positive side of y. Okay. Let's look at negative side of a, negative side of x-axis, I'm sorry. A units from the x-axis. Your r stays the same. A, in the case of a polar. But the angle is pi. Okay, the angle is pi. By the way, you could write it as negative a comma 0, which becomes identical to the rectangular coordinate system. But again, normally we are interested in the positive. I want you to know that a comma pi is the same as minus a comma 0, okay? Now, what about the negative side of the y? Okay, again, a units down, that means your r is a. We write as 0, comma, negative a using rectangular coordinate system. But polar coordinate system, your r is a, and the angle it makes is 3 pi over 2. 3 pi over 2. Sounds good, everybody? Any questions? All right, I think we are good to go, so we're going to move on. We went over this because those are, in essence, quadrantal angles, if you will. Everybody remembers quadrantal, angles R and theta, okay? What happens if a point belongs to the x-axis on the positive side or negative side, y-axis on the positive or negative side? How do you deal with it when it comes to a polar format? You should have a fairly easy understanding of that. On the positive side of x is the same thing, a comma 0. On the negative side of x is a comma pi, okay? For the y in the positive side becomes a comma pi over 2. And on the negative side is a comma 3 pi over 2. So I hope that's straightforward. All right, now we want to convert to polar coordinates given the pair 2 comma negative 2. And we start by plotting the point, okay? And then we determine r and theta, okay? So r is square root of x squared plus y squared. So that means first plot the point, okay? Now 2 squared, okay, I'm looking at r, 2 squared plus negative 2 quantity squared, they add up to 8. And r becomes square root of that. So first plot the point and then determine r and theta. So step 1 is to determine to plot the point. It's really helpful when we know where it is. So r is not a big deal, we found that. But what is theta? Theta is y over x, okay, tangent of that. So tangent theta is y over x. Tan theta is y over x. So what is theta? Tan inverse of y over x. Tan inverse of y over x. So I want you to see that it comes from this one, class. Tan inverse of y over x. That means tan inverse of negative 1. And that is negative pi over 4. So we have r and we have theta. Now we are going to write it using the polar coordinates. Okay, class? Well, one easy way, just use the numbers we came up with. So this is one way to write it. If you wrote this, you're done. It's end of the story, class. However, what if we want to use, let's say, positive angle? Or what if we want to use negative r, okay? So if we want to use positive angle, we just add a 2 pi to negative pi over 4. If we want to use a negative r, we change it to negative 2 squared of 2. and then we add a pi or odd multiples of pi to negative power 4. So in this case, I'm just adding 2 pi, okay, class? Add 2 pi. Now, if I want to change this to negative 2 squared root of 2, I'm going to add only pi. Only pi. Okay. Do we have to do that? Absolutely not. I'm just showing you that in case. Okay, class? Now, I'm going to go over the next page to give you an idea how you find theta. But honestly, the best course of action is graphing. Graph and make a decision because you can see the angle easily. Okay? So, but if we were to do it, not paying too much attention to the graph. By the way, everybody is okay with this? Is there any questions, class? So we are looking at polar coordinates. We are looking at plotting points and how we convert from one format to the next. All right. I really don't want you to pay too much attention to this because the way I look at it, I just do the math by first and foremost graphing my point. The given point, I plot that. And then from the location, I can see. Because if you look at part A, tan inverse of y over x, but if you look at part B, when you do tan inverse of y over x, okay, then it may not give you the proper, because remember the tan inverse is what? It goes from negative power 2 to power 2, okay? So what it really gives you some, gives you this angle, okay? That's why you need to add pi, okay, class? You need to add pi. But I wouldn't look at this, I wouldn't waste my time with this page, class. Plot the point, make a decision. It's that simple. Plot the point, make a decision. That's all there is to it, okay? So this is just, otherwise you have to keep on memorizing things and it piles up and it doesn't help. All right, but I showed you that in case. Here's another example that we deal with in this section, and that is, okay, how about if we want to transform an equation? If an equation is given in one format, how do we go to the other format? That's what we want to do. And we don't know the answer until we practice with some, okay? And drilling will do the job. In this case, look at r equals 4 sine theta. It's a polar format. We want to put it into a rectangular format. And by the way, sometimes we recognize and sometimes we do not recognize the equation, okay? Let's see what we can do. Anytime you have a case like this, the trick is simple. You all know that if you multiply by r, since r squared is x squared plus y squared, so the left side will become obvious. And the right side, look at this one. We know that y equals r sine theta and x is r cosine theta, okay? So if we multiply by r, this is the trick, class. It comes with practice. We are done in no time. Take a look. If we multiply by r, the left side is r squared, which is x squared plus y squared. The right side is 4 r sine theta, which is y. And you're practically done. We just recognize the type by putting it in standard form. Okay, before we do that, I hope everybody's following what I'm saying here. So there is a trick involved here. You multiply by r, it does the job. Okay. Now, the next thing you do here, you want to put this in standard form. You bring the 4y to the left, you put it together with y squared, and you try to complete this square. I hope you remember this one. So when you bring the 4y to the left, it becomes negative. And then here's your b, remember, to complete this square. Okay, you find b. b is negative 4. You divide it by 2. You square that. That's why we are adding 4 to both sides. So the left side becomes x squared plus y minus 2 quantity squared, and the right side is 4. I hope you recognize the equation of a circle in the form of, let me use a different color. X minus h squared, y minus k squared equals r squared. So circle is centered at 0, 2 with the radius 2. Sounds good, everybody? We will discuss the conic sections again, okay? It's the last part of the course. But I hope you remember this from intermediate algebra, college algebra, you know. So how did we go from polar to rectangular? We did the trick of multiplication by r, and it did the job for us. Does that work? Is everybody okay with that, class? Before I move on, I want to make sure everybody's in good shape.
At the top where it says to compute the, sorry, what's that?
To complete the square.
Oh, thank you.
Sure. To complete the square. That was the method. Sounds good, everybody?
Yes.
Okay. Now, we have a situation where we want to go from rectangular format to polar format. Okay, so actually this is not too bad, because on the left side, if you factor out the 3, what happens? We get 3 times r squared. And on the right side, we get 2 times x. What is x? Or cosine theta. In other words, we replace this one, and we replace this one accordingly. Everybody can see that. Again, we need to know x is r cosine theta, y is r sine theta, x squared plus y squared is r squared. And that's really the method, okay? You look for x squared plus y squared, you look for x, which is r cosine theta, and y, which is r sine theta, and that works out. If you don't have it, then if you have just x squared, then it's r cosine theta, you have to square it. So in short, this is obvious that we can do. If it's not obvious, change the x to r cosine theta, y to r sine theta, do the math, you're done. Okay? And so divide both sides by r, or you can even say R is a 2/3 cosine theta. Sometimes they stop here. Sometimes, let me use a different color. They specifically solve for R sometimes. Becomes 2/3 cosine theta. Either way is fine as long as you see a R and theta somewhere in the equation and you don't, okay, make sure you don't see X or Y. When you're done, when you have transformed it into polar, X and Y must be gone. Okay, class? Must be gone. All right. Let's look at another example, see how it goes, class. Well, we have a polar form and we want to go to rectangular form. Do you remember the trick we used in one of those occasions? And it practically can be used here. Can you see that, everybody? What trick do you think will do the job here? When we did, not the previous example, the one before that, we had R and then sine, and we multiplied by R. If you have R and cosine, we do exactly the same thing. So multiply by R. What happens? The left side becomes R squared. You have the answer, X squared plus Y squared. Okay. And then 6R cosine theta. You know R cosine theta is what? X. You're done. You do the same thing. You move the 6x, you complete the square, and you can answer the question. It's really very straightforward, class. So let's move the 6x. Okay. So can you tell me what we need to make this a perfect square? I'm talking about x squared minus 6x. What number should we add and why? Anyone?
3.
One more time.
3, we would divide the 6 by 2.
Okay.
And the square root, isn't that?
Okay. So
Should it be 9?
So
Yeah, right.
9, absolutely. Do you see that b is negative 6?
So it's negative 9.
Divide, no, negative 6.
Sorry.
B is negative 6. Divided by 2, negative 3. Square that, positive 9. So you add positive 9 to both sides. Okay. So now it's in standard form. It's a circle centered at 3, 0, with the radius being square root of 9, square root of 9, which is 3. Okay? Sounds good? All right. I want to do only one more question for tonight, class, and then the last page, I leave it for Thursday so I can refresh your memory about how we did this back and forth, okay? So one more example. Is everybody okay up to here?
Yes.
Okay.
Yes.
Excellent. All right. Now we want to go from rectangular form to polar form. And there is nothing there that we can, sort of use a trick or something. We just replace the x. X becomes r cosine theta. We also replace the y. It becomes r sine theta. That's all. So you replace the x, you replace the y. So you use this piece of information and you replace x and y. So you just multiply them. You get 4 r squared sine theta cosine theta. Now, normally we don't like to, if possible, we don't like to have sine and cosine, okay? We like to have only one of it. And I hope you see, everybody remembers the identity 2 sine theta cosine theta equals what? Anybody? What was it equal to?
1? No, wait.
Sine of 2 theta. So therefore, this 4, you can say it's 2 times that, and it becomes 2r squared sine 2 theta over 9. Sounds good? Is everybody okay with this?
Yes.
That's it for tonight, class. I'm going to pause the recording.